Okay, so today we need to understand valence electrons and how to determine how many valence electrons there are in a given element. We also need to be able to understand what's happening with these electrons and how things become ions so that we can prepare ourselves when we move into bonding. So the first thing we can do is take a look at the periodic table. We can see right here the number of valence electrons correspond to the numbers in black. So we can just simply count across periods or across columns 1, 2, 3, 4, 5, 6, 7 valence electrons for that column. So if I look at lithium, for example, lithium has 1 valence electron. If I take a look over here at a Bohr model of lithium, I see it has 3 protons. That comes from the atomic number. It has 4 neutrons. I'm going to round the atomic mass, 6.941, to 7 and subtract the atomic number. That gives me 4 neutrons. And it has 3 electrons, because in a regular standard atom, there will be an equal number of protons and electrons. And we can see that there's 2 electrons in the first energy level, and there can be up to 8 electrons in the second energy level. So for the case of lithium, there's 2 in the first energy level, and that leaves 1 valence electron. So a valence electron is an electron in the outermost shell. Fluorine has 9 protons. So it has 9 electrons. 2 in the first shell and 7 in the second shell. So you see in your notes there's this thing called the octet rule. The octet rule says that atoms, when bonding, want to achieve the electron configuration of a noble gas, which typically has 8 valence electrons. Helium is the exception to that. Helium only has 2 protons and 2 neutrons, and it only has 2 electrons. But its outer energy level is full because we only have 8 electrons in that inner energy level. So that's helium. So lithium wants to get rid of its outermost electron because it only has 1. It's really easy to get rid of that 1. So if this electron goes away, now this energy level is gone. And now it has 2 valence electrons just like helium does. In that case, lithium has become an ion. It now has 3 protons and 2 electrons. That's 3 positive charges and 2 negative charges. 3 positive charges, yes, and 2 negative charges. So it has an overall charge of positive 1. So in the case of fluorine, fluorine has 7 valence electrons. It wants to be like neon. Neon. Didn't leave enough room there. Neon has 10 protons and 10 neutrons. So it has 2 electrons in the first energy level and 8 electrons in its second energy level. Nice and happy. Fluorine wants to be like neon. So fluorine gains an electron. So let's say it gains that electron that lithium lost. So now it has 8 valence electrons. Now fluorine is an anion, a negatively charged ion. It has 9 protons, 9 positive charges, and 10 electrons because it gained 1. So in becoming an ion, it has gained or lost electrons. Lithium lost 1 electron. Fluorine gained 1 electron. And you can see that corresponds to the charge. So lithium has a positive 1 charge, which is here in red. Fluorine has a negative 1 charge, here in red. So in order to become, for an atom to have a positive 1 charge, it has to lose 1 electron. For an atom to become a negative 1 charge has to gain 1 electron. If we scroll down here a little bit, and that's what we see happening down here. So if we look at, say, calcium. Calcium has to it's right here, so it has a positive 2 charge, so it is going to lose 2 electrons. Oxygen, right over here, it's right there, can't see it at the moment, oh wait, there's oxygen. Oxygen has a negative 2 charge, so it is going to gain 2 electrons. Alright, so that's ions. Now we just have to understand valence electrons. So if we look back at our periodic table, we started the conversation saying that lithium had 1 valence electron and fluorine had 7 valence electrons. And I can just, again, count that over. So if I look at potassium right here, potassium is K. It has 1 valence electron. Carbon is right here. It has 4 valence electrons, and so forth. When drawing a Lewis dot diagram, all I'm going to do is, instead of drawing this complicated Bohr model that has a whole lot of information I don't necessarily need, I just want to make a diagram that only deals with the valence electrons. So if you look at calcium, calcium has 2 valence electrons. I'm going to always put my electrons in pairs on the 4 sides, but I'm going to start putting them on sides individually. So I'll start on the left and the right, or you can do the top and the bottom. Potassium has 1 valence electron, so I'm just going to put 1 dot. Argon, Ar, is a noble gas, right here. So it has 8 valence electrons, which we see right there. So I'm going to put 4 pairs. I'm going to space them out. So again, they exist in pairs on the 4 sides of our symbol. So argon symbol is Ar, and there are 4 pairs of dots, each dot representing an electron. So that is a Lewis dot diagram. As we move through the unit, we will use these diagrams to show